I'm Giulia Rubiu, a PhD student at the University of Cagliari. Today, on behalf of myself and the other authors of this article, I'm delighted to present our work on digitization and design for social innovation. Specifically, we have developed a co-design model for prison spaces. During this presentation, I will provide a detailed overview of our research and the outcomes we have achieved. This is the table of contents. This paper presents the findings of a survey conducted to explore the potential application of building information modeling, virtual reality, and augmented reality tools in the design process of juvenile detention centers. Through a specific case study, the research highlights the key advantage of computer and network technologies, maximizing interaction between designers and stakeholders, thereby bridging the gap between technical expertise and common knowledge. By employing inclusive methodologies supported by suitable technological tools, the test design and co-decision model successfully address the challenges faced by non-expert users in understanding technical documents. Additionally, these models facilitate the incremental approach to design, evaluation, and correction, enabling the project to evolve through successive interaction while considering the holistic nature of problems and action and their interrelationships. Critical issues in the architecture of detention centers in Italy revolve around inadequate spatial design, perpetuating a segregating paradigm and hindering re-educational and re-socialization goals. The lack of quality living and working environments compromises the well-being of staff and inmates. Rehabilitation opportunities are limited due to the existing architecture's shortcomings. Insufficient user involvement, including the exclusion of key stakeholders, hampers effective design solutions. Language and technical barriers impede communication and collaboration. Hybridized approaches, such as co-design and inclusive methodologies, are necessary to address these challenges. The design of prison facilities in Italy is a topic that has been overlooked and lacks public debate within the traditional architectural and urban culture. There is a lack of specific text, menus, and research in this area. The existing detention centers are standardized detached from the urban context and primarily focus on meeting social defense needs. However, there have been a few architectural experiments aimed at educational and resocialization of inmates. In 2015, a public consultation was initiated by the Ministry of Justice to address the architectural aspects and reform of penal institutions. On this occasion, it has been considered essential to promote a dialogue among the various stakeholders to define new design criteria that bestow architectural dignity upon the space and penal execution. The proposed methodology is co-design, actively involving stakeholders in all stages of the process, combined with the use of building information modeling. It is strategic for actively engaging stakeholders and identify critical issues, opportunities, and needs. The methodology will be described in great detail alongside the case study. The project was born following the agreement between the University of Cagliari and the Center of Juvenile Justice. The pilot project aims to involve prisoners and operators in the reorganization and improvement of their living and working spaces within the penal system. It utilizes a co-design approach where stakeholders collaborate with designers through the process. The use of building information modeling methodology and tools is strategic in facilitating stakeholders' involvement and identifying critical issues and needs. The project focuses on a specific building within the Institute for Juvenile Justice in Sardinia, Italy. The building requires maintenance and suffers from design issues, such as a repetitive and anonymous cell arrangements, inadequate furnishing, and a lack of identity. The project proposal for the Juvenile Penitentiary focuses on the workshops located on the second floor of Pavilion E. The objective is to create a new configuration of spaces that promotes social rehabilitation and improves the quality of re-educational journey for inmates while maintaining a high level of supervision. The redesign workshops support a strong focus on professional activities while the use of digital tools, allowing for a variety of planning educational activities and projects by the penitentiary administration to facilitate training in different areas. The proposal incorporates elements of flexibility in the space, including rotating panels installed of doors, a reading room and media library at the center of the area, the presence of safety glass and natural light, and revitalization of the outdoor area for the sports activities. These recognize the educational value of sports in the recovery process and preparation of inmates for their reintegration into society. In the reconfiguration of the outdoor spaces, the design proposal addresses the need for effective supervision of inmates in a large area. Officers stationed with a 360-degree view have been included to ensure proper surveillance. The project includes an editable soccer field for both inmates and the community, promoting engagement and potential self-financing. The second zone features a beach volley court, shady areas, an athletic track, and surveillance station, enhancing recreational and social opportunities. The use of building information modeling throughout the design process allows for clear and efficient communication with stakeholders who may not be familiar with technical drawing. The parametric model and Revit software accurately representing the design intervention, including demolished and rebuilt elements, quantitative and qualitative data, along with feedback from various stakeholders such as the warden, educators, teachers, psychologists, volunteers, prison police, and inmates, inform the design choices. The parametric model facilitated the creation of photorealistic renderings for realistic virtual representation of design. There are two types of VR techniques: non-immersive and immersive. Non-immersive techniques allow users to interact with the virtual environment using conventional tools like a keyboard, mouse, and monitor. Immersive techniques offer more realistic experiences, where users are surrounded by screens placed in a cave automatic virtual environment, or wear a head-mounted display for a fully immersive experience. Both immersive and non-immersive VR techniques can be integrated with the building information model. To address the limitation of BIM models and renderings in conveying spatial properties, the design process incorporated virtual reality. VR provides a more comprehensive representation of the design choices, facilitating greater stakeholders' involvement in the evaluation and validation of the intervention scenario. Questions were extracted from the central model developed in the initial design phase using auto-descriptive software. The integration of a smartphone with Iris VR Scope app allowed for the visualization of VR panoramas on the smartphone itself using Google Cardboards for an immersive experience. This immersive VR experience enables stakeholders to better understand and assess the design choices made during the project. Augmented reality is an interactive graphic system that allows one to act on a video image stream, modifying reality by adding, in real time, virtual content and animation. While at first this technique may be confused or overlapped with VR, AR differs significantly from VR. The difference between VR and AR is that in the first case, one is observing on a screen the projection of a fictitious world made entirely of virtual objects. In the second case, what is being imaged is an integration of real images and virtual objects. Interactivity is another key concept. The virtual objects that augment the video stream are not static but can perform movements and animation in response to human actions. The Augmented application allows different users to enter and share several models in the different formats allowed, including OBJ to visualize the model, reference elements, marker or fiducial symbols must be created. These are elements that are recognized very easily by the camera software, which can have different shapes and characteristics. Often the QR code is used. In this specific case, to visualize the model, a floor plan of the building was selected as the marker. When the application installed in the smartphone detects this marker, it understands the location of the model, which is subsequently displayed. The software allows the content of different formats to be associated with the model: text, video, photograph, etc. The AR technologies implemented in this specific experimentation allowed for overcoming language barriers concerning foreign inmates. Importing the central model into the open-source application Augmented allowed different users to enter and share the building model in the OBJ format. In our case, the application allowed texts and dimensions to be displayed according to different languages and measurement systems to support communication with a multi-ethnic user base. In conclusion, the integration of building information modeling, virtual reality, and augmented reality has transformed the design processes into an inclusive and participatory experience. By involving marginalized groups and leveraging innovative tools, we have fostered a sense of belonging, improved dialogue, and created alternative design models. This approach not only enhances the quality of our projects but also empowers individuals and promotes social inclusion. Together, we are shaping a more inclusive and equitable future through design innovation.